Hello. Hi. Hi, everyone. Hi. Welcome back to everyone. We are recording. All right, we're good. I have a series of announcements, actually, to start off with today. So I'll go ahead and get going with that. And then I want to offer you all a chance to kind of ask questions. Obviously, you can ask questions like at any point during the lecture. But if there are sort of specific things that you're wondering about, independent of what I'm actually doing, on the screen, that's great. So getting into our announcements, first of all, I want to just quickly mention that I was a little late uploading our lecture material from last class. So I went ahead and did that. That you all probably don't care so much about that, but I'll have it on record in the recording. Most of you were here, so yay. That's how it does work. So in any case, we had I just had a really crazy week and I forgot. Yeah, it happens. So for today, I have a few announcements. If you're in Natalie Lambert's sections, hi Zinchen, I might actually point at you for just a second. So if you're in Natalie Lambert's sections, I just wanted to inform you of a couple of things. Natalie's okay, but she was in a very bad car accident, and she's not going to be teaching with us for the rest of the semester. So all I know for sure is that she had some intersection with a large glass object, and she had to get a lot of stitches on her arm, and she also is not able to walk right now. So we're basically just giving her, time until, for the rest of the semester to heal and figure out what she needs to do medically. So yeah, she's okay, but it's still kind of early. It's been only a couple of days, so we don't really know exactly what might be wrong with her, because some of that stuff takes a while. So major love to Natalie. So Zinchen is a graduate student from our department who's going to be taking over for Natalie. And so Zinchen has actually been using code for a long time, so it's really convenient and awesome that Zinchen's available to help us out. So if you're in Natalie's sections, you're going to be working with Zinchen for the rest of the semester. Also, I wanted to deliver another message to people in Natalie's sections, and that is that if you're waiting for your grades to happen, I was informed by Natalie that she was a bit behind, so I am going to be catching up her grading. So whatever grades you have minus the 2 code assignments that you'll be working with Zinchen on, I will be personally grading your assignments. Ha, ha, ha. Don't worry, I'm an easy grader. So anyway, yeah, so that's pretty much what's happening. So I'm hoping to get whatever grading that I have to do done by the end of the week, because I think that just needs to be prioritized. And then, the rest of the grades will be a combination of me and Zinchen working together, I think, to get those together. If you have any questions about the sort of TA situation, feel free to send me an email or whatever. Okay, so that was the major announcement. And then we had that minor announcement. Anything else? Other things happening? It's kind of a big thing. Awesome. Well, so let me just kind of walk you through what the next 2 weeks are going to look like. So today I'm going to be talking about ChatGPT because we didn't get to that last class. We're also going to be talking about for loops in a little bit more of a robust way. We're going to be thinking about, okay, well, how do you actually use for loops in context to make a color fade or to make something look like a tendril or that type of thing. So we'll be looking at more applied examples of for loops. And I'll also be talking a little bit about rotation. And we'll be talking a little bit more further about color as well and some of the examples I prepared for today. On Wednesday, we're going to spend most of Wednesday and into Monday, this will kind of overflow into Monday, we'll spend that really thinking about interaction and how you use the keyboard and mouse to sort of interact with, whatever you have in your sketch, whether it's shapes or, images or whatever. So we'll be really thinking mostly about keyboard and mouse interaction for those 2 days. And then on Wednesday, I'm hoping that we will have time to look at this lecture on algorithmically driven art. And then we can spend some time doing a final review for the final exam, which just sort of another reminder that the final exam is on May 11th, and you get that 24-hour window. So that window will open up on midnight May 10th, and then it closes midnight May 11th. I will say that in this iteration of the final exam, some of the questions are short answer, where they ask you to actually complete things. In general, I think that in the lecture slides, you hopefully are familiar with this by now, that there's a sort of slide with study questions. They're for a reason. They're there for a reason. So that would be my number one tip. Yeah, okay, well, let's jump into P5 for a little bit. So basically where we left off last class, I can go ahead and comment a couple of things out just so it looks, I'll go ahead and type this stuff in from scratch just so we know exactly what's going on. So this is basically the example that we left off with last class, except last class we used an ellipse instead of a rectangle. It just so happens that the arguments that you type into ellipse and rectangle are exactly the same. It's x, y, width, and height. Right now this is honking at me because it's not a comment, so it was thinking like, oh, if it's not a comment, which is this double slash, then it thinks it's an active line of code, and it's not a very good active line of code, right? So it's kicking up that error. And so at this point, this is pretty much exactly where we left off. We have a for loop that has 3 parts in it. I'm just going to go over this stuff so you kind of remember. We have the variable declaration portion where you're creating a variable. In this case, the variable is called I. That's a really common convention. And then here, you're saying if I is less than or equal to 100. And then here, I is basically you're adding 10. I plus equals 10. So that will iterate the I variable by 10 each time you go through that. And so the for loop is basically going through in the following way. If I go ahead and unclick this auto refresh button before I type an empty print object, I can avoid locking up my computer, which would be nice. I'm going to print I here. And you can see in the console that I is basically going anywhere from 0 to 100 in steps of 10, right? So just to show you kind of how that breaks down on the for loop itself, here's our 0. So it starts at 0, it goes up to 100, and it's incrementing in steps of 10. Personally, if you're asking, which you're not, but I'll tell you, the sort of for loop that I use most commonly, it's a for loop that has I++, and I just go up by 1 number each time. The only reason I'm using 10 in this case is because I actually wanted to have a little bit more space, and I wanted to use that number to control the y coordinate. So that's all fine and good. This should be review. What happens if we would try to actually rotate this? I think that's one of the ways that we can start to get into what you might be able to do with for loops. So one way would be to create a variable. In this case, I'm going to create a variable called A, and I'll use point 1 as just a starting variable. And I can use the rotate function. Now, this may or may not be what you expect. So, what's happening here? Well, you can see that it rotates by 0.1 between this square is being rotated 0.1, right? You can also see that this square is being rotated a tiny bit more. This square is being rotated a tiny bit more, and a tiny bit more, and a tiny bit more, right? Is that the way rotation is supposed to work? Not according to most people's sort of common sense understanding of it, usually. So this reveals something that P5 and most programming languages, for that matter, have, which is called, and you don't have to know this, it's called a transformation matrix. And so basically what happens is when you're sort of adding this rotation, it's not actually rotating the object, it's rotating the entire coordinate system. Okay? So if we were to, let's say, just for sake of argument, add another rectangle outside of this for loop, you'll be able to see pretty clearly, I think, how that works. So here, maybe I'll start this rectangle at 200 and just give it a regular numerical value there. Okay, so I'm actually slightly surprised that it did that, but let's go ahead and do it like this. Okay, so that's what we would actually expect. And right, that's kind of fine, but what you need to understand is that if you make another iteration of the rotation, because in the for loop you're actually calling rotate 10 times, right? That it's just migrating that matrix. So you probably are thinking, well, gosh, there has to be a way to stop that. And yeah, guess what? There is. It's kind of its own standalone function. It's called push and pop. And so when you activate push and pop, they have to be in pairs, and they have to be wrapped around the rotation function and the thing that you're rotating. And when you use push and pop, you can basically turn off that feature. And so now you can see that all of the individual blocks are being rotated exactly the same amount, right? So this is kind of a concept that becomes pretty important if you're doing like animation or stuff like that. But I think in general, like people make it more complicated than it needs to be. But I think the biggest thing to maybe remember is that rotation in most programming languages is kind of like a string. And if you don't cut the string, it'll just carry through to the next thing, right? You'll just like be carrying it with you through the forest, right? And the push and pop functions, they exist in multiple programming languages. Those are basically just ways of like resetting the coordinate system. And so you need that, or you need to do that when you have like a lot of different objects doing different things on the screen, basically. So it might not be as clear like why we're doing it here, although in a for loop is a pretty good place to start to look at that. But yeah, it's an issue that it really just depends on what you want to do. Like personally, I'm a huge fan of not using push and pop and allowing the rotation to like get weird. Because personally, I don't know, I just think it's more fun that way. But let's say, in this case, the rotation is still 0.1. We could start with this one little thing, and if you have a push and pop disabled, we can go into the regular part of the draw loop and say something like A plus equals 0.001. And so we're basically just taking the value of A and just adding a tiny bit to it every time the draw function iterates. And then you'll start to get something that looks like that. it will come back around eventually. It'll just go around in a big spiral. There we go. And so, yeah, you know, it can be kind of fun to just play around with the unpredictable results that you might get. If you want something to go a little bit faster, delete a 0. If you want it to go a little slower, add a 0. That's all you have to do. Now, another question that you might be asking yourself is, why are these numbers so tiny? Like, why is 0.1 the starting point for rotation when I know and you know that 360 degrees makes a circle? Well, so the answer is that P5 and its sister language, and pretty much every other programming language that I know of, doesn't work in degrees. It works in radians. And so radians, if you're not familiar with radians, to make a circle in radians is 2 pi. So that's like 6.2 blah, 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 something like that. No, I'm not one of those people that has the digits of pi memorized. But I know and care about people like that. That's definitely like a pretty important sort of system variable in processing. So let's maybe do like a little experiment. Let's try to take whatever this rotation value is. We've got, hopefully we have 10 objects here. I'm going to try to actually find out what would be sort of like freestyling it a tiny bit. So if I take this rotation for A, which is 0.1, let's say that instead I want to go in a completely different direction where I want to take this rectangle and I want to rotate it so that it'll be evenly lined up around the center of the screen, okay? So basically what I want to create is like a ring of rectangles that are kind of orbiting around the center of the screen, okay? So first of all, we have to kind of think about what the center of the screen is. So that happens to be, there's an easy way to kind of talk about that, and it's width divided by 2, height divided by 2. The nice thing about doing it this way, rather than just typing these numbers in, is that when you change your sketch later on, you won't have to update this part of the code. And if I want to actually make everything change its 0 point to this point, I would use the translate function. So translate is a little bit like rotation in that it uses this transformation matrix thing that I mentioned. And so, okay, well, it looks like it is sort of rotating around the center, so that's a kind of lucky thing. But it's not really doing what we wanted it to do, which was I was actually hoping that we would have fixed rectangles that were kind of placed evenly around a circle and that they would just stay there. Okay? So in order for me to do that, I'm going to have to do a little bit of math. Sorry, it has to happen. So it's only a tiny bit of math. So let's say I have this sort of circle here. And basically what I'm trying to solve for is whatever this is. And we can just, for sake of simplicity, we can call this x. So if we're thinking about well, what is x? X is actually some function of this, right? So in this case, we have, let's see, 100. We're moving in increments of 10, so we have 10 things. And we basically want to rotate we want a rotation value that I can use A because it just has this static value put into it, so I can just change that. So A would equal, in this case, 2 pi divided by, we could do divided by 10. That should work. And then this becomes our rotation point. So that is basically what we get. And that looks pretty close to what I was looking for. I do think that maybe bringing the rectangle in to the center just a tiny bit closer would be like helpful for us to kind of see what's happening. So I'm just going to move these coordinates in a little bit. Now, it's also important for you to kind of understand that this may be, well, this is iterating up. We're using I in the value here, so that's probably not the greatest idea. Right, there we go, perfect. So one thing that I just want to make sure everybody understands is that where is 0, 0 right now? 0, 0 is right here. So if we want to just kind of test that out, because we made this translation function, I could do something like, okay, let's draw a rectangle right in the middle here, and let's draw it at 0, 0, just to kind of make sure that we drive this point home. And we'll keep it at 50 by 50. Now, it might look like our rectangle is not drawing at 0, 0, but it totally is, and I'll tell you why. In P5, there's a function called rect mode that dictates whether the rectangle draws from the center or if it draws from the corner. And right now, the default is that it draws from the corner of the rectangle. So we could even change that like a little bit in the setup function. So that's one of these awesome setup things. And I can just type center. Not in French, though. It's frowned upon. And so now you can see my rectangles are just sitting a little bit differently, and they're kind of finding their home at the center. So this is sort of like in a very quick nutshell, like how push and pop works. By the way, if we wanted, now we have push and pop commented out here. If we wanted to use them, it might not be the best fit because it would basically put all of our rectangles at the same location. So here, if we're using push and pop, I would have to actually iterate by A every time so that it adds onto itself, right? So I could sort of do that, I guess. I mean, I'm not really sure why you would do that when you could just use, not use push and pop, which is kind of an easier way of getting the same thing to happen. But sure, I'll show you how that works. So A plus equals A, and so probably the fact that we're recalculating this in the for loop, we're actually doing this math in the for loop, is probably not the best choice. I'm going to just take this one statement out of the for loop because it's having like a tiny little order of operations thing there. And so let's see. Well, in any case, this is how I would do it, is to not use push and pop in this case. But let me make sure that that works. Yeah, there we go. So we can come back to that later if we have time. I just want to make sure that I move through everything in the time that we have. So I'm going to go ahead and grab this code and kind of capture this as it is right now, and then we'll open up a new tab for some stuff. So the other thing that I wanted to make sure that I've kind of covered today was I wanted to make sure that I covered using color in a kind of iterative way. So we're going to work with the same code, except I think I'm going to make it a little bit different. Here I'm asking for this rotation value to be 10. Let's try 100. And maybe here, let's do I++ instead of I plus equals 10. So this is a maybe more typical for loop where you can see it's just got a lot more shapes, right? It has an order of magnitude more shapes. And so that's great. We can kind of start there. So one thing that I would really like to do, mostly because it's springtime and I'm standing here like waiting to be convinced that it is actually springtime, I'm going to kind of go for some sort of bright colors. So I think we're going to go for a little bit of the rainbow palette. So just like there's a rect mode function, there's also a color mode function. And that color mode basically just allows you to choose between all of these different color modes that P5 has available. So for the most part, we've been using the default, which is RGB. And there's nothing wrong with that. I actually find, though, that for certain things, RGB color is actually a lot more difficult to use because you have to know whether you want to, take numbers out of the red channel or the green channel, and it's just kind of like a lot. So one of the reasons I love HSB color is because when you're coding, it's very easy to navigate the color spectrum with something like a for loop. So in this case, we're going to say, all right, we're using HSB, which stands for hue, saturation, brightness. So it just so happens that we're going to keep saturation and brightness pretty much up at full blast. And then with hue, that's a single kind of parameter that we can just iterate through in a for loop. We can go from 0 to 255. Now, when I've gone ahead and switched over to HSB color in this line of code, I did something to make things a little bit more, easy is the wrong word, convenient for myself as the coder. I changed the range of the available colors in the color system to 100. And what is awesome about 100? It's divisible by 10. And yeah, it's divisible by 10. You know what else? We have 100 shapes. Oh my God, it's like I planned it. So otherwise, we'd have to take the 255 range and we'd have to squeeze it into 100 shapes. And that sounds like math. So, we might not want to bother with that. This is a lot easier. So yeah, I'm making this thing 100 pixels, or 100 units, basically. And so here I have my rotation going, and basically this is going to be pretty easy. What I have to do here is I have to go ahead and put in a fill. And a normal fill in, if I were doing this in RGB, it would look something like this, right? And that is just not going to work at all because we need these numbers now. Because we've typed in 100 here, that means that any time we use a function where we're giving a numeric value to color, it has to end at 100. So we could certainly type just 100 here if we want these at full blast. And then we want 100 here. And here, I'm actually can just put I from the for loop in there. And I also forgot to close these parentheses. And so that is pretty much how you make a rainbow. If we wanted to kind of like push this just a little bit more aesthetically, we could certainly think about maybe adding a stroke, or even better, maybe no stroke. Gradient land. So strokes are fun. I mean, it depends on what kind of aesthetic you like. If you like things to look sort of, you know, like they have outlines, that's great. I would suggest that at least once or twice you take your sketch and just get rid of the stroke, because when you get rid of the stroke, you have to actually deal with the interaction of color. And that can be like a really beautiful thing. So where colors kind of bleed into each other, right? So yeah, you can definitely get that going. And probably, I think I'm going to do that thing where the rotation value increases a bit. So right now, my rotation increasing is not really working because I'm using this value for A, and it's being recalculated every time I run the draw function. So a smarter way to set this up, now that I kind of am here and I know what I want to do, a smarter way to set it up would be to put this calculation actually up here. And so then we should be able to get the benefit of this change in value. Oh, this might be a good time for debugging. So the other thing we can do, if it's not letting us make this calculation here, is you can instantiate the variable up here. I'm just going to try this, and then if this doesn't work, we will start ChatGPT debugging. There we go. Yeah, so basically the reason that that was not working is because I was trying to use a system variable outside of the setup or draw, which, you know, it's just cranky. Doesn't like it. So yeah, you can see here that this is kind of moving along and doing a thing. Probably, it might be useful to just turn this off for 1 second and take another look at what this is actually doing. Okay. So we've got this translation happening here. And we could call push and pop if we wanted to, but I'm not really sure that it's strictly necessary. But I'm going to go ahead and do it and just see what happens. Yeah, not so much. So it's interesting, it's somewhat interesting to me that it looks like it might be looping around more than once, because this is only going from pink to red, which is just a little curious. So if we're taking, I just want to take a look at this and like make sure that it's actually what I want to do. So we're taking A as 2 pi divided by 100. So what happened there is I actually just reduced the rotation like by an order of magnitude. And by doing it this way, it lets you kind of see through the entire color spectrum, which is what we're actually pulling from the hue separation value. This is the part where I can just get lost in like experimenting with all of this stuff. But I think that this basically like fulfills the job of showing you how to do this. I think one thing that I also always forget to do is I forget to save my sketches and log in, and so that's something that I'm trying to just remember to do in general. It's possible that if I have an opportunity to kind of like revisit these before I upload them, I can certainly do that. let's take one more sort of stab at this and get rid of the rotation for now. So I'm going to get rid of the rotation entirely, and that should give us, let's see. Alrighty, so right now, nothing should have changed because I have not really. Just going to comment out this for loop so that I can really focus on this. So right now we have basically no rotation, and that's fine. I'm just going to get rid of this entire line of rotation. I just want to provide a simpler example of looking through kind of a color spectrum. So here, I think we could probably start our x at 0 and then have it go to something like, I don't know, 200 maybe. Nope, too far. Let's see, and I think we also, for this, I'm going to make it iterate just by 10. Okay, no stroke, fill, blah, 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 blah. Okay, don't need this. Don't need that. And okay, so basically here I would want to just have I as the yellow. And so this is just going to function like if you're looking for a much kind of more straightforward way of dealing with color and not having to deal with the rotation or anything, this can be in there as a sort of more simplified example, because I wouldn't want to confuse people if they're not doing stuff with rotation. So let's go ahead and take this code now that we've kind of gotten this far. Let's take this code and let's break it. So that's my favorite thing to do is breaking stuff. No, really not, but it's fun to think about. So I just broke some stuff. I think I could probably also maybe like get rid of that. So I just created 2 syntax errors, and then there's also a curly brace error. So there's not a chance that this would run, but as you notice, like when you run things in P5, especially the P5 editor, it doesn't really tell you what the error is. It tells you the place where it hung up, which is usually just after the error, okay? Sometimes could be helpful, but it's not the most straightforward, error checking system. And guess what? Pretty much every programming language like in the world is like that. So if you're thinking about getting into coding, like loving mysteries is part of the sort of required attitude. And so that being said, I'm going to go ahead and show you how to deal with this in ChatGPT. Now, I'm sure that many of you have probably tried ChatGPT for various different things. It's good for certain things. It's not good for other things. We're kind of starting to kind of get a little bit of a consciousness there. But if you want to send it your code, you should put your code in the clipboard. So in other words, here I'm going to select all the code and do a Command or Control-C. And then I'm going to come over here and I'm going to say debug this p5.js code. And then I just put a colon and type the code. Now, what's really brilliant about this and why I feel really pretty good about using this as a teaching tool is that I feel like ChatGPT does a much better job of explaining error checking than the P5 system does. So it's going through the code, and it will actually, once it does that, it will fix the errors, and this is the part that I think is really great. It actually explains why those things are errors. And I've done this like many, many times. It does a pretty good job, and I have not had it say anything factually untrue, because I'm not asking it like, if my code enjoys, taking naps with my cat. I'm asking if my code, is basically conforming to the guidelines that are published, right, on the internet. So for this one thing, I would say that, yeah, it's pretty brilliant. So it said here, corrected a syntax error by adding a slash. So that was our first error. And I believe our other errors were a little bit deeper in. Oh, no, actually, maybe right here. No? So are any of you engaged in classes where faculty are showing you like constructive ways to use ChatGPT? It's like you're only learning how to use it for evil? That's great. That's funny. Okay, so it's getting through the second for loop. It does take a little bit of time. It's being a little bit slower than it has been in the past. So it fixed the curly braces on the draw function. It also fixed this syntactical lack of a slash here. Yep, that's what I was referring to. And then it added, oh, now this is interesting. So it actually added a let I equal 0 here. And I mean, that's very nice of it to do that, but obviously it's not necessary. So that's where one thing I have noticed about ChatGPT and how it interprets p5.js is that it tends to favor sort of the pure syntax of JavaScript on which p5 is based. It's not something that will give you any issue, though. So every once in a while, it'll throw in some sort of pure JavaScript syntax that in P5 wouldn't matter so much. But that's not really a problem. That's like a bonus. Yeah, and so then you get this sort of, thing. And so apparently, this is hilarious. It added push and pop into my function. And I have to tell you, I fervently disagree with that choice, but I think that that's where you kind of have to come in and say, like, no, I want it to rotate all over the place, or whatever, So if you're getting the effect you want, and then it's cool. So this really reminds me of something like back in the old days that was called the HTML validator. Where you would basically get a bunch of errors, and some of them were real errors that you had, to fix, and some of them were like, if you want your code to be, fully compatible with Eritrean computers from 1970s, like, then do that, and you're just like, no, I don't care. But yeah, so y'all are gonna have to really decide, like, some of these are more like choices, and some of these are like, code does not run without doing this, right? So I think some of you probably have also maybe thought about like doing your assignments in p5.js, and so I can definitely demonstrate that. So I think the last thing I tried was in p5.js. Draw an image of a cat in pixelated style. So that doesn't seem like a super hard thing, right? Ha ha. But wait. And actually, sorry, I should probably open up a new chat for that, but it might work. Okay, already, I have to say, lame. So already, it's using JavaScript syntax here. This is not P5 syntax. It's also suggesting that you basically make your cat by loading an image into P5, which is like the lamest possible way you could do it. And then, yeah, it's just not like, it's not a great way. And the other thing, I can absolutely guarantee that this cat.jpg is, I mean, you don't, did I say draw a sketch where I need to have my own image ready? I did not. So yeah, it's disappointing. I did do it at one point. Oh yeah, here we go. So it did come up with this for a slightly different prompt. And I can show you what this looks like. This was the point where I realized that, honestly, it would take probably a good bit more work to make ChatGPT poop out what you want rather than just learning something. That's my opinion. So, yeah, and then this narrative can get out of here. So this was the cat that I asked it to draw, where it actually produced it at one point. Is it even running? Let me see. Syntax error, blah, blah. Interesting. Oh, yeah. Right? Isn't it beautiful? Yeah, it's like, I'm a cat. So, I mean, this is super typical, like, of the P5 attempts that I made in ChatGPT, where a couple of things that I just noticed. It centered the object in the screen every single time. It also used the default window size, which is 200 by 200 in this case, so it's really small window size. It also doesn't write the code in a way that is parametric, so if you blew up the window, you could actually blow up the illustration. So also, everyone knows that the whiskers go next to the nose. Like, come on. So yeah, it was, I would say, universally like somewhat disappointing. What it is good at, if you're thinking about this type of code, like if you asked it to do something like where you had the specificity of like one of those Solowit pieces, right, where it's like draw an arc that goes from this point to that point, and then draw another arc that goes from this point to this point and is this color, and you could be like crazy specific. But I would also make the argument that if you can be that specific, you can write some code. Like, it's just not that hard. So yeah, I feel free to experiment, but I definitely think that there are a lot of things that you can do with it that are really, really helpful and really useful. But drawing cats, sadly, not among them. So yeah, I think that's pretty much enough for today. I know that sounds like a pre-end of the year yawn is what that sounds like. So I will be uploading examples from today, and I will definitely be reaching out to chat with people, well, just to kind of like give people a heads up in Natalie's section about when I'm going to do the grades. And yeah, that's about it. Have a great couple of days. A shark! That's brilliant! I love it. See, now if you took that and like, repeated it or, like did something to it, that would